Hello guys, today we will discuss about the stereoisomerism of monosaccharide. What are the stereoisomers and what are their types? There are three types of stereoisomerism. One is epimerism, second is enantiomerism, and third is enamerism. Epimerism and enantiomerism discussed in state structure orientation, which is known as Fisher projection, and enamerism is studied in the ring structure projection, which is also known as Schwarz projection. So, what is stereoisomers and stereoisomerism? First of all, we check the definition of it. The monosaccharide which have same molecular formula but they differ from each other by the orientation are three-dimensional orientation of H or OH groups in space are known as stereoisomer, and the phenomena is known as stereoisomerism. There are three types of in this type of isomerism we see the orientation of radicals of H and OH groups. Around the chiral carbon or around the anomeric carbon or around the any three chiral carbon, four chiral carbon to denote D and L. Then, first of all, we discuss about the epimerism. The monosaccharide which have same molecular formula but they differ from each other by the geometric or orientation of H or OH groups on any chiral carbon atom. In space are known as epimer and the phenomena is known as epimerism. What is chiral carbon? Which have four different groups on it. Chiral carbon is that carbon which has four different groups attached to it. Mannose, C2 and Galactose C4 are the epimer of glucose. They differ from glucose by the position of OH group, H and OH group on second and fourth carbon. This is the structure of a glucose. In glucose, we have a third carbon hydroxyl group on left side. This is the general structure of a glucose. If we deviate the position of H and OH group on second carbon, this is second carbon. Then this glucose is changed into D-mannose. This glucose is changed into D-mannose. And if we change the position of H and OH group on fourth carbon, this glucose is changed into D-galactose. So these two are the epimer of what glucose. Similarly, we can have 16 epimer of glucose according to want of food. According to want of food, what is the formula of want of food? C n power 2. It means n stand for number of chiral carbon. If the number of chiral carbon will increase, the number of isomer of the given compound will increase. Asymmetric carbon or chiral carbon is that carbon on which four different groups are attached. According to want of rule, which have formula C 2 की power n, C 2 की power n, or 2 power n. N stand for number of chiral carbon. If we have one chiral carbon, it means there are two epimer possible. And if we have four chiral carbon, it means 16 epimer of glucose are possible. Then enantiomerism, the monosaccharide which have same molecular formula but they differ from each other by the geometric orientation of H and OH group on penultimate carbon atom in space are known as enantiomer, and the phenomena is known as enantiomerism. In enantiomerism, we have D and L form. In enantiomerism, we have D and L form. In enantiomerism, we have D and L form. D for dextrorotatory and L for levorotation. It means if the penultimate carbon hydroxyl group on the right side, it is known as D monosaccharide, and if penultimate carbon have hydroxyl group on the right side, left side, then it is known as L monosaccharide. Okay, D and L forms are the mirror images of each other, but they cannot superimpose on each other. Like if I see the mirror image of right hand, it looks like left hand in the mirror. So D and L forms are the mirror images of each other. This is the D-glucose because penultimate carbon. What is penultimate carbon atom? Second last carbon. This is sixth carbon. This is fifth carbon. Second last carbon is known as penultimate carbon. If we have hydroxyl group position on the right side, then most of the hydroxyl group position are on the right side. This is known as D-glucose. And if we have a hydroxyl group position on the left side, then the most of the hydroxyl group have a position of hydroxyl group on the left side. So penultimate carbon atom is the dominant member to see the D and L form. This is the D-glyceraldehyde. This is the reference compound. Glyceraldehyde is the reference compound to check the D and L form because it has only one chiral carbon. Then enantiomerism is only studied in the ring structure. In enantiomerism, we have a racemic mixture. If we have 50% D form and 50% L form of a monosaccharide in a solution, this is known as racemic mixture. So racemic mixture have 50% D form and 50% L form. If we plan polarized light bombard on the racemic mixture, it shows no deviation, either right side or left side. So there is no optical activity. If there is no optical activity, it means there is a racemic mixture. To check D and L form, we use an instrument which is known as polarimeter or NMR. Enantiomerism, the monosaccharide which have same molecular formula but they differ from each other by the orientation of H or OH groups on anomeric carbon atoms in ring structure are known as enantiomer, and phenomena is known as enantiomerism. There are two forms of present in the enantiomerism. One is alpha form and other is beta form. So for ring formation, penultimate carbon atom take on the carbonyl carbon atom in functional carbon atom. Then the radical on the right side oriented downward and radical on the left side oriented upward. So we have ring structure. Mostly penultimate carbon atom attack the functional group of carbon, which is known as carbonyl carbon atom. So this is Haworth projection. This is Fischer projection. So if the hydroxyl group is in the cis configuration, mean both fifth and last carbon hydroxyl group and first carbon, in the case of aldehyde, first carbon is an anomeric carbon. In case of ketone, second carbon is an anomeric carbon. So if the orientation of radical on the first carbon is the upper direction, this is known as cis configuration. This is known as beta glucose. And if the orientation of sixth carbon and first carbon change transconfiguration, this is known as alpha form. It means hydroxyl group is in the downward direction. This is the structure of fructose. Fructose in which fifth carbon penultimate hydroxyl group attack on the second carbonyl carbon atom. So if the hydroxyl group is downward, this is known as alpha form of the fructose, and if hydroxyl group position is upward on the second carbon. In case of aldehyde, first carbon is the anomeric carbon, and in case of ketone, second carbon is the anomeric carbon. Anomeric carbon is that carbon which is achiral before ring formation and become chiral after ring formation. Here, in case of glucose, first carbon is the anomeric carbon, but in case of fructose, second carbon is the anomeric carbon. We see the position of hydroxyl group only on the anomeric carbon. That's all. What is the mutor-rotation? Racemic mixture we have already discussed. What is resolution? The process of separation of pure enantiomer from their racemic modification is known as resolution. Then we have mutor-rotation. The optical rotation is changed gradually until the constant rotation is changed. This phenomenon is known as mutor-rotation. Glucose dissolved in water, its optical rotation gradually change from 1 degree to 52.5 degree when solution is low to stand. Not using sugar except mutar rotation, but not using sugar does not show any mutar rotation. Mutar rotation may be studied by changing the NMR, IR, mass spectra. That's all. If you like that video, please subscribe that channel. Thank you.